Hi everyone, it's Professor Hall. So today we are going to talk about the science in the book Wrinkle in Time. And this is a lecture that I'm going to call Theoretical Physics for people who never majored in theoretical physics. I have a degree in English. I've been an English professor for over a decade. My hair is crazy right now, like a mad scientist, right? So I'm going to explain things in kind of a rudimentary way and then discuss how they are used in the book and how they're featured in the book. And then in the notes for this lecture, in the show notes, and also in Blackboard, I'm going to paste some links for the explanations of these things from people who actually teach physics or cosmology or astronomy, as the case may be. So, having said that, let's get started. There are three basic things that I want to talk about today. The first is the idea of the fourth dimension. The second is dark matter, and then the third is gravitational waves. And in that precise order. I had planned on doing this with my drawing pad, and I was going to have things drawn kind of on screen. I know that the light is so bad in here, but I do have things on a notepad that I'll be drawing on and I'll be showing you, and you'll be seeing it likely backwards, but nevertheless it will be there. So, dimensions in A Wrinkle in Time. To briefly explain, one dimension, let's see here, one dimension is a line. You can only move one way, forward and back. I have this numbered because if you remember from when you were younger and doing math, we were often given a number line. The reason is that having a number line is a good beginning first understanding of geometry. And when you have a number line, there is only one number used because it's one dimension. So there's just one number used to describe where you are. So let's say that we have little smiley face Megan with curly hair right here, and I would describe my location as being a 2 on the number line. So happy face girl equals 2. That's my location. Then we move into 2 dimensions. And we're working with this on a 2-dimensional surface. So when we get into 3 and 4, it should be interesting. 2 dimensions is sometimes depicted as a simple shape, like a square, instead of just having side to side, which is our first dimension. We also have up and down, which is our second dimension, right? So if you have ever seen, I'll draw it out here, the X and Y axis, that's basically what this is trying to depict. So I might have those same ticks that I had on a number line, and I'll put a dot right there, and I would explain that as being 3 over and 3 up. So my 4 over. So my coordinates for my location have 2 numbers to describe them because we're now in a 2-dimensional space. So it's not just this line, it's up and over. 4 over, 3 up. Those are my coordinates. So this again would be 2 dimensions. 2 numbers, 2 ways of moving, 2 dimensions. With 3 dimensions, we add a third component. So let's say that instead of just a square, we have a cube, and I'm drawing it so that you can kind of see through it. And of course, if you know anything from watching TV or movies, everything is 2D, and then you can put on 3D glasses so it looks like it's coming out at you. So it's not just moving side to side, up and down, but also in and out, like my hand right now, coming at you in almost 3D. So let's say that this three-dimensional space is a house, and we have, I'm going to draw kind of rudimentary way here, a second floor. And here I am as this person. I'm in the kitchen cooking dinner. So, and I've apparently won like, there we go. So, how would I describe where I am? Well, this time I'm going to have 3 numbers. I'm going to have the length, the height, and then the width or the depth in drawing it inward. Again, a little bit difficult to do. So this way, and this way. This is called the z-axis, basically. If you had an x and y, and then there's the z to show the third dimension. So then I would have 3 numbers. I would have, let's just say I am 6 feet over, I am 10 feet up, and I am 2 feet in. 3 numbers to describe where I am. Those are the 3 dimensions. And some people would say these are all the dimensions we have. Some people would say these are all the dimensions that we're able to perceive. So we have a 2D object. We have a 1D object, just one line. We have a 2D object, a drawing on a piece of paper. We have, I almost turned it wrong, a 3D object that has height, width, and depth. Right? No longer that 2D, there we go. No longer that 2D surface on paper. Depth, there's stuff in it that I can drink. So, water because I'm a little parched. Sorry. My Christmas cup in the middle of April. So, the book talks a lot about the 4th dimension. The 4th dimension is kind of controversial. Some physicists believe that the 4th dimension, and I'm going to look this up on my notes that I don't mispronounce the name, but there is this depiction of the 4th dimension kind of like this. We've got these like 2 funnels connected by a plane. The top funnel is the future. This plane is our current, it kind of should bisect here, but this is our present, our current understanding of what's going on. And then this down here is the past, what has occurred already. This concept, now that I'm going to figure out where I put this in my notes, Minkowski space-time. That's what it is called. So you have time passing through here, going this way, one directional only kind of. Time. No arrow down there, one direction. That's time. I probably should have drawn it closer to the arrow. And then you have the point right here where they meet, and that's the person doing the observing. And then this is kind of the space. So some science fiction stories look at space-time in this way, and they say you can move through time but not through space. So in essence, if you have something like in Back to the Future, the DeLorean, I forgot the name of the car in Back to the Future. Oh, what kind of a nerd am I? The DeLorean in Back to the Future moves through time, but spatially it's the same way. So at one point, Marty is told you're not thinking fourth dimensionally. There is a precipice where in the future a bridge will be. In the present, the bridge is not there. But when he crosses it in the future, he's in that same time, in that same space, even though the time has changed. When he leaves and is in the parking lot of the Hill Valley Mall, he's still in where the mall will be in the past, right? So the space-time continuum, the theory there is that if you could travel through time, you could not travel through space. Another depiction of this fourth dimension is called the Tesseract, and that is what we see in this book. Now, it's depicted in a couple different ways, but essentially the theory is that if a third dimension is a cube, which I will draw again for you, there we have our three-dimensional cube, that the Tesseract would be, I'm going to draw it on a little bit of an angle so you can see it better, almost like a cube within a cube, like that. And that then as this moves through space and time, it's often depicted, it looks almost like a three-dimensional cross. So you have, I'm just going to draw it out real quick here. So you have this idea that basically this cube within a cube is somehow moving, changing, that kind of thing. And this is going to be pretty hard to see. With my Expo dry erase marker, but I'll shade some of it. So it's kind of like that. And typically you get a line here as well. Okay, so it kind of looks like this. But a 2D depiction of this is really inadequate. And so is a 3D because we're talking about a fourth dimension. So that is what a tesseract actually is, a cube within a cube. There is a All the Small Pretty Things, I think it's called, on Amazon Prime, a movie that talks about fourth dimension, and there are people who are stuck in a kind of a Groundhog Day situation where they're reliving the same day over and over and over, and that's because this tesseract has occurred, this wrinkle or problem in time similar to this. So the difficulty with the fourth dimension is that some scientists, as I said, think that the fourth dimension is space. Some think that it's something else that we're not able to see. Some think that there are 6 dimensions. Some scientists think that there are many more. And so this is the realm of theoretical physics that we have stumbled into with this book. And the important thing to note here is that she's using the term tesseract, that basically a tesseract is a concept of a fourth dimension, that it's really hard for us to depict this type of fourth dimension because our brains think three-dimensionally, and that she's using this concept to talk about wrinkles in time. So unlike Marty McFly, or unlike H.G. Wells' Time Machine, where the time machine is at a fixed point and time accelerates or decelerates around it, the depiction that we get in the book is the same idea that's used later in, I think Carl Sagan wrote it, the story Contact. The movie Contact comes later, the book is not later. That you have a piece of string, and there is, in this case, an ant, which is a good metaphor for people in this large universe, trying to walk from one side of the string to the other. And the closest, fastest way to go from point A to point B is not a straight line. It is to bring those two parts together so that basically our little ant, there's the string in between, goes from point A to point B pretty much simultaneously. Now, this is not an unusual concept in fiction, but you do have a lot of later stories kind of playing around with this, that there's some kind of a portal that allows us to travel. If you think back to Margaret Cavendish, we had the lady on the boat sucked up through a portal into a new world at the North Pole that has no real scientific explanation. C.S. Lewis in his books, who Madeleine L'Engle was quite familiar with and really thought of herself kind of in the same realm of writing, being a Christian fantasy writer, he has one of the Narnia Chronicles features this woods where there are ponds going to different worlds. Again, a fantasy, an imaginative way of trying to explain these concepts of science. And in Stargate, you have a Stargate that takes people from one dimension to another and sometimes through time. In Star Trek, the idea we're going to talk about in a minute with gravitational waves is kind of used to explain how 2 points are coming together. So basically in that show, it would be a wormhole that there would be a cataclysmic astronomical event that your ship is in Star Trek, not Discovery, I don't think, Voyager. Star Trek Voyager, there's a ship that gets caught into a wormhole and they find themselves traveling through a small amount of space in a very quick time. Again, not quite bending both space and time, but here space is bending and they find themselves in an outer quadrant and it's going to take them hundreds of years to come home. So this is something that's been used many different ways in science fiction. And the title Wrinkle in Time is really playing around with this concept. So there's basically, in terms of the book, I'm so sorry for playing with my hair, it's driving me nuts. Basically, in terms of the book, there are two ways of thinking about this. The first is that scientific idea of what if and can it be done and how would it happen and all of that. And this wrinkling of time that allows Dr. Murray to travel from one place to another and what goes wrong with that and how he's kind of then pulled in to this adventure and then how his children go on a quest to save him. The other three things. The other thing is that from Madeleine L'Encle's point of view, again, she is using fantasy to try to explain phenomena. And one of the clips that I'm going to put in these show notes is a physicist who says, this is theoretical. These are things that we are guessing at. We look at the universe and we say, there are things here that do not fit our scientific understanding of gravity, of electromagnetic fields, of particles and how they work. And so there must be something else that could explain it. And they come up with theories, and that later on, perhaps, yes, by practical physicists or astronomers, these could be tested. But when you look at astrophysicists, a lot of what they are doing is guesswork, trying to figure out if this is true, if this is not. Is there one universe? Are there more than one? Are there two? Are there multiple parallel universe? What does string theory mean? And how does that have multiple particles that kind of either are below the first dimension or beyond the first dimension, something that we can't exactly see? How does quantum mechanics play into this? And you know what? Many people cannot understand these concepts. So how are you going to explain them to children? Well, what you're going to do is have other children be on a quest and talk about ants moving across a string and talk about and have fantastical elements where, you know what, we can't explain it. So why not throw a little magic in? And why not have a little bit of spirituality? Because there's some things that you just have to take on faith. And that really is the core of this book. The belief that sometimes we need fantasy and imagination to explain things because science isn't going to explain things fully. And also, I want to say this too, the book was published in 1962. So a lot of these concepts we know a little bit more about now, 60 years later. But certainly at the time, and she herself is not, as far as I know, an astrophysicist. So I think it's really fascinating. And I also think that these are things that children can read and become interested in and then maybe study when they're older. And they're things that adults can read in this book and appreciate them because they have a little bit better understanding of them. So another concept here is dark matter. And kind of going along with the theme of things being explained through fantasy. I want to read to you a little bit about dark matter from my notes here. So the idea of dark matter is that there is mass or particles or energy that we are not able to completely see. So again, unexplained phenomena. Dark matter was first theorized in the sorry, something happened with my computer here. There we go. It was first theorized in the late 1800s, so around 1880, 1890. And really not, I don't want to say discovered, but that's not quite the right word. But I will say, I guess I'll say discovered. The observation of how it works was kind of discovered in 1933. So about 30 years before the book was written. The premise of dark matter is basically this, that there are, again, things out in the universe that we are now able to observe, but that we do not understand. And when physicists look at this, they say, based on our understanding of things like gravity and electromagnetic waves and particles and atoms, there's some stuff going on here that doesn't seem to fit any of the understood and tested scientific theories. So one of the things with dark matter is that basically you look at a galaxy and it's not pulling itself apart completely, and it's somehow staying together, and yet there are not bodies that would hold this gravitational force together. So therefore, the theory is that there are particles that we cannot see, but whose evidence we can detect. So things like dark neutrons, dark electrons, gravitinos, that there are these particles that are helping everything stay together and that work on some kind of a physical level that our understanding of physics is kind of beyond that. The other thing about dark matter, so that first part about dark matter really goes with what I was talking about. We're using fantasy to explain these abstract physical concepts. The second thing about dark matter is that, like Willy Wonka's chocolate factory, nobody ever goes in and nobody ever goes out. So it does not emit light, and it does not allow light to pass through. This is one of the reasons that we can observe the effects of dark matter, but dark matter or dark particles themselves have not yet been actually observed. So the idea here, does she talk about dark matter in the book directly? No, not the way that she talks about a tesseract and the way that maybe space-time can be bended. But she does talk about these fantasy concepts that are related to dark matter. And so she has this motif of the dark and the light, the good and the evil. And there are places that the light cannot touch. There are places where the light shines more brightly. We have the planet of Casmots, which is a dark planet. And there seem to be things going on there that have to do with both love and social concepts of justice and conformity and utopian versus dystopian societies, but also that the darkness here is both figurative and literal. There literally is dark matter surrounding some of these places, and there is literal light that cannot get through. And then, of course, figuratively, the darkness standing in for evil and the light standing in for good. So we talked last time about the light shineth in the darkness, and the darkness understoodeth it not, from the Bible. And then the children talk about Jesus and Gandhi and Euclid, which we're just talking about with geometry. Einstein's theory of relativity, which has a lot to do with the concepts in this book about space and time and the gravitational waves we'll talk about in a moment. And then this darkness that is trying to consume, and this 20 years before Stephen King's It, this thing that is working for the darkness that is trying to pull it down. Now, of course, too, we get this kind of mixed in with fantasy and religion, where there's God and there's evil, and that God has possibly angels and sometimes people to kind of help fight this evil. But I do think that the concept of dark matter is here to a certain extent. So kind of look for that. Where are we talking about the physical and the literal, and how does that play into the figurative and the fantastical? The next thing that I want to say going along with that, we did talk about just a second ago gravitational waves. And to try to depict this for you, and then I'm going to read something from Caltech that I think explains it really well. So I'm going to, how can I kind of, okay. I'm depicting this a little bit differently than it's depicted a lot of times online or in peer-reviewed papers, just so you can kind of see it. So this is a black hole and this is a black hole. And these two black holes, I'll do it with a little dotted line here to show, have been pulled into each other's gravitational fields, and now they are orbiting each other. What happens is that from this cataclysmic event, it looks like an omelet. It looks like I just fried an egg. Because of this cataclysmic event, when they draw closer and closer and closer to each other, that there are these gravitational waves, these wrinkles or waves in space and time. So the way that Caltech explains this, gravitational waves are ripples in space-time. Oh, I did it. That's what I wanted to say. Some caused by some of the most violent and energetic processes in the universe. Now, they're talking here about Albert Einstein, but this is actually something that was theorized in about 1905. Einstein's theories of relativity in 1916 explained it further, but they were kind of devised a little bit before him. Einstein's mathematics in 1916 showed that massive accelerating objects, such as neutron stars or black holes orbiting each other, would disrupt space-time in such a way that waves of undulating space-time would propagate or go forth in all directions away from the source. These cosmic ripples would travel at the speed of light, carrying with them information. The strongest gravitational waves are produced by cataclysmic events, colliding black holes, supernovae, which are massive stars that explode at the end of their lifetimes, and colliding neutron stars. Other waves are predicted to be caused by the rotation of neutron stars that are not perfect spheres, and possibly even the remnants or the remains of gravitational radiation created by the Big Bang. So, one thing about the Big Bang that we're going to hold for later. But the idea here, two things. Number one, that this is another kind of wrinkle in time. I think that there are three types that I'm going to mention at the end. But this is another type of wrinkle in time, and this time it's caused by a cataclysmic event. So the first type of wrinkle in time that is being talked about here is the bending of space and possibly space-time to travel long distances, to possibly travel through time, to bring point A and point B together like a wormhole or a portal. Through the idea of a tesseract, where you can kind of somehow understand and see a fourth dimension and then bend it. The second type of wrinkle in time, sorry for yelling, the second type of wrinkle in time is this idea of the gravitational wave. She does not use this term, but we do have one of the characters who is a star and talks about how she was a star, and they talk about how she fought hard, and that then she somehow was fallen or somehow killed, and basically it's an interesting way of blending fantasy and religion and science, that she's possibly an angel, possibly an alien, doesn't matter. She's a being that was fighting for the good in the world and the light, and as a star, she was bringing that light, and that somehow the darkness attacked, she did not survive that, and possibly the idea that she went supernova. So this is kind of connected to the third idea, that what you do in the world and what you say has ripples or wrinkles, and that if you're fighting for good, the results of that fight can be felt later on in time. That somebody sees you fighting and so they fight harder, right? Or that you say a kind word to someone and that then that person feels better about themselves and then they go out and they do something good, right? That kind of pay it forward kind of thing. Like at Starbucks or McDonald's, when somebody pays for somebody's order and it keeps going for 84 cars. So the opposite is true as well. That you can have someone doing bad in the world and evil, and what ripple effects does that have? In this case, it's the taking over of an entire planet and the killing of a young star and putting out her light. So these ideas of wrinkles in time, I think, are played with in this book in a variety of ways, and I'd like you to look for all three of them. How do they talk about this woman's life and what became of it and how she fought? How do they talk about the darkness and the light? How do they talk about the wrinkling of time through the Tesseract and both Dr. Murray's research? And how does that play a role in the way that the children are on this quest, both to defeat the darkness, the evil in the world, and to physically travel through the universe? At one point, they are on a 2-dimensional planet. I forgot to mention that, and they can't breathe because they're 3-dimensional, which I love so much. I just think that that's such a little touch and a little hint as to the importance of these dimensions in this book without really getting too much into it. The last thing that I want to say is the creation of the universe is never completely touched upon, though there are some hints to evolution. I mentioned just now the Big Bang Theory. For Madeleine L'Engle, she was asked about this, and I don't know if I still have the clip or if this is an interview that I read with her, but basically she said there are two things in her mind: that God created the universe and that the how is secondary. That the primary thing for her in her faith and her understanding is that there is a God and that God created the universe. So I think that you can see that a tiny bit in this book as well. Again, do we get into Genesis versus and pure creationism of God saying a word and things coming to being versus a Big Bang versus evolution or a combination of all those? Not necessarily, but I think what you can see here is this belief that she has that science and God are not exclusive, and that God definitely in terms of the universe that we're looking at and her belief system, God created the universe. And how he did that was possibly by using science and possibly through supernatural means and possibly a combination. And that there are mysteries of life. And that these mysteries can sometimes be understood. And sometimes we just say, you know what, we're not going to understand that. And that's okay too. But even within not understanding the details, that we should have a better understanding of truth. And I think that you can see that message in this book. So this is the third time that I recorded this because the first two I got very in depth into the science and not so much how it's used in the book, I think. And the second, I talked way more about the book and I didn't explain the science well. So I hope that this was a good explanation because I'm not doing it a fourth time. I'm not doing it. I hope that this is a good explanation. I hope that you understand some of these concepts a little bit better and see how they're being used in this book and how they're being explained for kids, but how adults can understand it too. And I hope that you have a better appreciation of the book. And I can't wait to see all the discussion about it. Thanks, everybody.